all. So we had a little bit of a different setup planned for the talk, but then Ralph made bad life decisions yesterday and lost his voice. So we decided she should suffer. And so he'll actually start off the talk by basically picking up where he left off last year at the same conference and talk about debugging native code running in WebAssembly, so Rust code. So Ralph, please do talk as you can.
It'll be fine. No, really, there's no problem. So.
And at any point, if you want me to do a voiceover for your demo.
This is my last opportunity to talk. So, what happened last year? Natalia debugged a web page and dove directly into the dwarf. And right from VS Code, and everything worked perfectly. I like being quiet because now you have to sort of pay attention, even if you don't want to. So this is Natalia last year, and it worked fine, straight into the Rust. So then I debugged the core Wasm module locally, the same one, and it blew up in my face. So that's me, and I'm upset. But worse, I like components, and I couldn't do components. The debuggers wouldn't attach, and they wouldn't find any breakpoints. So, this year, we can start with components. And the static stuff is now easy. I'll give you a look. And after that, somebody who talks can show you the tough stuff. So I'm going to use the Rust component sample in the Code Alliance repository. It's very simple, WASI HTTP. Okay? So if we pop out of here, and we go over to VS Code, this is a sample, right?
Oh.
We lost the projection somehow.
Did you maybe only share the window?
I didn't share anything. That's the interesting part. No, that's the screen. There we go. Apologies. So that's the sample. So you can see this is just a very simple HTTP server. It's exactly the same thing that you would expect. It is a component. And so we can set some breakpoints in the home and so forth. And in VS Code, if I switch to the launch, you can see that I'm just using LLDB, right? So I'm using Wasm time as the process I'm debugging. But this can be any process. So the same configuration will work with WASM or Wasm Edge, Wasm or whatever you're talking about. It's just a process from the point of view of the computer and the debugger. So even though it's debugging into WebAssembly, it's all the same. There's nothing fancy here. So if we go back to our little thing, you can see we got some breakpoints set and so forth. And if we hit F5, we go ahead and build the component, right? And that's going to go over to a website. And we'll go over here and find our little website. And when we hit refresh, of course, it'll work fine, right? It works so fine that you don't even notice that you've hit it. So from now, you can just keep on going, no problem. Then you can go in and release. And sure enough, it all works. That is dead simple now, even with components. It's really cool. And if you have questions about this, I will whisper to you answers at the booth.
Ask him lots of questions.
Yes, torture me. And of course, I just keep going. I release it, and it slept for that long. Just count it. So everything works. I'm really happy about this. I used Rust, but all the statics are fine. C, C++, all that kind of stuff. So I showed you what happened last year, and we go back through that. I'm still embarrassed, and I'm no longer sad. Now, however, we get to the really fun stuff, and that's what Till's going to show you.
And for that, we need to switch over to the other computer. OK. Man, these slides are a lot more boring. I apologize. So to explain why there's a difference, it seems like, well, if debugging works, it should work. We are debugging things running in Wasm time. Why isn't this a universal thing? To give some context to that, I will do a speed run through what I'll show. So I'll show JavaScript debugging in WebAssembly, and I'll quickly talk through how we're even executing JavaScript. We are using the JavaScript runtime Starling Monkey, a bytecode lines project based on the SpiderMonkey JavaScript engine that also powers Firefox. And that allows us to run large parts of spec-compliant JavaScript code as that it exists out there right now. And this slide is kind of at the heart of what's different here. So same as with the Rust component Ralph demoed, it targets WASI, running inside and runs inside of a component, but as opposed to the way the Rust component worked, Rust compiles to WebAssembly bytecode directly and runs without any meaningful runtime. And that means all the values, if you have a string, then it's a string that exists in kind of the usual way on the heap or the stack. And if you have stack frames, they exist as stack frames in WebAssembly. And LLDB knows how to interpret those things and knows how to facilitate debugging them. JavaScript is executed very differently. It's executed in the SpiderMonkey engine, combined with a bunch of built-ins to support things like the location object, fetch, request response, streams, text encoding, decoding, those kinds of things. And then the code that's actually executed exists just in memory and is executed in a way where it doesn't use native stack frames that LLDB could look at and so on. So we can't use LLDB at all for this. Additionally, it's running, so in addition to using Starling Monkey, we're using another bytecode lines project called Componentize.js, which basically allows you to take a weird world, in this example, JS shell, and generate bindings for it and give you a new Wasm file that is specialized to this weird world. And then what you get out is this amended diagram. The JavaScript is still exactly so same setup, but now you're not just targeting WASI, you're targeting a custom weird world which can add whatever you want to add to it. By the way, all of these slides I stole from another Starling Monkey core contributor, Tomasz Andrzejczak from Microsoft, who's been doing fantastic work since starting to contribute last October. He's been doing amazing work expanding the web and spec compatibility of Starling Monkey. And he gave this presentation in a much better way in a meeting a while ago. OK, so that all context. debugging. I didn't really talk about debugging here so far. As I mentioned, it's very different in that we don't have native code. We're actively not interested at all in debugging the WebAssembly bytecode. In building Starling Monkey, we are, but in using Starling Monkey, you don't want to look at the bytecode. And that means Dwarf doesn't help you, LLDB doesn't help you, all of this. Instead, we are using the content debugger that is built into SpiderMonkey, and we are connecting to an external debugger, in this case Visual Studio Code, via the socket connections that the WASI sockets interface provides. And that, in turn, means it's usable in production builds. You don't need to have special debug symbols built in and optimizations turned off and so on. And it also means it's not specific to Wasm time, as the other solution is. So what Ralph showed doesn't work in any runtime needs to have its own implementation of this dwarf-based debugging. With this solution, we don't need this. And I will now show, I should probably embiggen this a little bit. I'll show this code being debugged, and for that we need to target a world that has a bunch of things. This actually has more things in it than are needed. Really, the important parts are these lines here. The incoming handler is needed because currently in Starling Monkey, that's the point where we check for should we debug. In a future version, we'll extend that to any other export so that you can use it more generally. But right now, that's a limitation. And then the lines above it, these 5 here, are needed for the debugger to actually work. The first one is needed because we are passing a port to connect to for debugging in via a command line, an env, and the other 4 here are needed for the actual socket connection. We can then use componentized.js, as mentioned before, to turn our main.js file here into a component, and we have to pass this as a runtime arg to Starling Monkey, the enable script debugging. Otherwise, Starling Monkey won't check whether it should connect to a debugger at runtime. So I'll run this, and now you can see this executing top-level script. That's not a built-in thing from componentized.js. That's just this line being executed, because one property of Starling Monkey is that it actually takes, at build time, it executes the top-level code of your JavaScript application and takes a snapshot of the result. And that means at runtime, when this fetch event handler is invoked because an HTTP request is coming in, none of that needs to happen. So if you have costly initialization logic for your application, you can do it, you should, as much as possible, do it at initialization time, and then you kind of hit the ground running if a request comes in, because this is actually the first line of JavaScript that's executed at runtime. Okay, now that we have this build, we can see we have a launch configuration here that is of type Starling Monkey. This is a VS Code extension, the Starling Monkey debugger. It's published as a pre-release right now. You can install it just via the VS Code marketplace. I can start. I don't know where the echo is coming from. I'll, for the moment, pretend it doesn't exist. And I can go here to the debugger and start this connection or the launch configuration. And we'll see here that we now have a new terminal open in which Wasm time was started with a whole bunch of config flags. Those are all pre-configured to allow debugging for it. And we see here that we have a part where things are being served, and we see that we immediately hit the code here because in our launch configuration we have stop on entry enabled. And as I mentioned earlier, this is the first line of JavaScript that is being executed, so that's the first line the debugger sees. And from here on, we can step through things. We can see values here as one would expect. And if we, at some point, continue, we see the output of this. So yeah, that having a Hello Universe seems okay, but I feel like we should be a little bit more specific. So let's set a breakpoint here, and then I will continue until I hit the breakpoint. And then let's see, where are we again? We are at Wasm IO. So I will change this here and then run the next line where the response is being created. I'll continue. And we have hello Wasm IO. So this is all cool. It's kind of similar to what Ralph showed. It's still running in Wasm time. Let's change that part. And actually, this is all overridable in the launch configuration, but I'm not good at live modifying anything, so I will instead change it here in my settings, and I will change from Wasm time to Jaco, and I'll remove a whole bunch of stuff here. And I actually should have left serve in place. So we now have Jaco serve component, and if I now rerun things, it should have stopped Wasm time. It didn't. So let me try that again. Now we see we have Node running here, and we because Jaco is taking the component, the starting monkey component, with our main.js compiled in and turning it back into a set of core Wasm modules and a bunch of JavaScript glue code so that it can run in Node, which doesn't have native component model support, but this is actually about on par functionality-wise. And Jaco by default uses the port 8000, so we'll change this to 8000, and we're hitting the same breakpoint now, running JavaScript in Starling Monkey, in a WebAssembly component, in JavaScript, in Node, talking to VS Code. And everything works the same, so we can step through all the same. We hit the breakpoint again, and so on. So this is all, it's a universal experience. It's not specific to the runtime. All you need is the ability to execute components by whatever means, including turning them back into core WebAssembly. All you need is the ability to have an outgoing socket connection. And that's actually an important part. You don't need to run a socket server. Normally, the way debugging usually works is that you have a debug server that you need to run where you're doing your debugging. So LLDB can serve as a debug server if you debug remotely on, for example, you debug iOS or Android application, then you're running a debug server on the device that your environment connects to. This is sort of inverted, which means we have the much less scary thing. We just need an outgoing socket connection, and we don't need to find a route, which in turn also means we can do this remotely. I was hoping that I would be able to wire this up, but I ran out of time before the talk, so that'll be maybe a follow-up next year, who knows, being able to do exactly all of this post-deployment in a live environment, in your production context. You can just send a special request saying, hey, here's my debugging request, here's an authentication key, and then it connects back to your environment, and you can actually debug without redeploying, because all of this works without any changes to content, as I mentioned. So yeah, that's basically what we have to demo for today. The next steps here are coordinating with other languages. We already know we want to talk about unifying this with .NET, and Python is on our agenda, and be able to use maybe the same extension, ideally even in VS Code, to debug these different things, because none of the protocol, VS Code, doesn't need to really know that this is JavaScript. It's debugging. It just needs to know something is sending me the right messages about breakpoint locations and stack layout and so on. And then, building on this, a big part also of why I've been doing this work is as effectively pathfinding for eventually a standardized solution where runtimes would play a role again, because this is right now, because it is fully in content, it doesn't allow you to step from one component to the other and have a unified workflow there. And because the component model is a lot about enabling you to compose applications out of different building blocks in different languages, the ultimate goal here is to allow you to have a debugging experience where you see a stack that spans these different components, and that allows you to step through, and just if you import a function from another component, you step into it, and now you're all of a sudden in C#, where before you were in JavaScript. That's the next step. I hope to be there maybe in some version next year, maybe 2 years from now. We'll see. And I think that about wraps it up.
Thank you. Thank you.
Thank you. Any questions for Ralph?
Any questions?
He has to talk more. He needs it.
Thanks very much. Appreciate it.
Yeah.
Be outside.
Thanks.